Welcome to this tutorial on connecting databases to automated tests using Playwright, and why not even Cypress. I'll walk you through the process using Mongo DB, Dynamo DB, PostgreSQL, and MySQL. We'll first set up these connections locally, and then incorporate them into a Gitlab pipeline. Once you grasp the general approach, you can apply it to any database. Let's start with Mongo DB. I'm using a MacBook here, but these steps should work on any system. We'll run Mongo DB in a Docker container, so first fire up Docker Desktop. Next, search for the official Mongo DB image on Docker Hub. Here's the Docker command to run it. We'll just need to specify the version and port for external access. Since I didn't already have this image on my machine, it'll download now. Let me fast forward so we're not sitting around waiting for it. Once the container is running, it's a good idea to check its status in Docker Desktop. Looks like it's up and running. If the status said stopped, it would signal that something went wrong. Now, let's verify the database is running using Mongosh. That's the Mongo DB shell, and it looks like everything is running smoothly. If you don't have the Mongo DB shell installed, just search for it online. You'll find the official Mongo DB documentation with installation steps for Windows, Mac, and Linux. Now that our database is ready, we can install Playwright. Playwright sets up a handy template for the test environment, so we can dive right into writing the test script. When connecting tests to a database, the first step is to find a suitable database client for your programming language. In our case, the Mongo DB node driver is what you'll need. You can find installation instructions and usage examples on their official page. To install the client, just type npm install MongoDB. With everything in place, it's time to start writing the test script. I'll tidy up the example a bit, then import the Mongo DB client. First, we'll define a few variables: the database address, client, database name, and collection name. Then, we'll set up a before-all method. This runs before any test and ensures the database is cleaned from any previous run, recreates the test table, and inserts fresh test values. While you could do this via the command line or other methods, I'll handle it here, so we can cover some common database operations. I'll also add a try-catch block because database queries sometimes need specific error handling. You'll see later on where this comes in handy. Next, I'll define the DB and collection variables. We'll name our database TestDB, and the collection will be dogs for a practical example. We'll add some dog breeds and their colors. The first operation clears out test data from the previous run. In case your previous test wrote or modified values, you need to reload the initial data. Clearing the data at the end of the test isn't ideal because you might want to review it when something goes wrong. That's why we'll clear it at the beginning of each run. To clear the collection, we'll use the delete many method with empty curly braces as the parameter, which clears everything. Next, we'll insert some data that we can later fetch in the test. I'll add a couple of dog breeds and their colors. Now we're ready to write the actual test. We'll retrieve one breed from the collection and verify that its color matches. I'll also print the entire response to the console so you can see what we get. I'll close the Mongo DB client at the end of this test. In a real test suite, it's best to handle this in the afterall method, or even in a global teardown. For simplicity, I'm omitting those details. Finally, we'll rename the file properly, and we're ready to run this. And here are the results. You can see the response object, and our assertion passed, so the test passed. As you can tell, working with MongoDB is pretty straightforward. Just a few steps and nothing unnecessary. One feature I particularly like about MongoDB is that you don't need to explicitly create tables. Just give the table a name and start inserting values. MongoDB takes care of the rest, which is a great example of how good tools can simplify your workflow. Alright, let's move on to the next database, DynamoDB. I've got Docker Desktop running in the background, and now we need to grab the Docker image for the DynamoDB local database. I'll also walk you through how to run it on AWS Cloud. Here's the command to get started. Props to Amazon for including the port parameter. It's something other official database images missed. It's usually the point where a beginner developer gets stuck for a couple of hours trying to figure out why the database isn't accepting connections, even though they followed all the instructions. Now we've got DynamoDB running on localhost at port 8000. Next, we need the AWS CLI command line interface. You can find instructions on how to install it on Linux, Mac, and Windows right here. After that, we'll configure AWS CLI. I'll use these values as secret key. I guess they wouldn't work in real cloud database. If you're using the cloud version, enter your AWS region like US-East-1. To test if the database is working, just run the command AWS DynamoDB list tables. If you're interested in using DynamoDB on AWS Cloud, I'll show you how to get your access key values. Log in to the AWS console, click on your account, and head over to Security Credentials. You'll find a section called Access Keys where you can create new ones. Now we're ready to start writing the test. I've got a blank template here, and the first thing we need is to grab a database client for our programming language. Here are the installation instructions. Next, we'll import the client and define a variable to point to it. When you instantiate the client, you need to set the region and endpoint for the database. If you're using a cloud database, make sure to specify your AWS region, like US-West-1. Following our usual pattern, we'll clear out the test tables from any leftover data from previous runs, recreate the table, and insert some test data. I'll use a try-catch block here and instantiate a new delete table command. Oh, and I need to import the commands I'm going to use. Moving on to deleting the table, we'll stick with our dog breeds theme, and at the end I'll print the response to the console. Now we'll run the first part of the test. We're getting an error because the table hasn't been created yet. It seems the delete operation works, but we can verify that later. Next up is creating the table. This requires a bit more code, so let's grab an example from the docs and tweak it for our needs. There are two attributes in the example table, but we only need one for the breed, so I'll get rid of the other one. The attribute type S stands for string. We'll need the attribute definition and also include the same field in the key schema. The provisioned throughput defines how many times per second the table can be accessed, but we'll leave the defaults. Looks like we're ready to see if this works. I'll wrap this in its own try-catch block and then run the test. We got the same error from the delete table command, but nothing about create table. Turns out I forgot to log the response to the console. Let's fix that. If the table creation worked, we shouldn't see any more errors from the delete operation. And it looks like we're good. Alright, moving on. Next, we'll add test values to the database. First, I'll define the item we're going to insert into the database. We need to set the table name and the fields for the item. In this case, the fields are breed and color. Now I'll instantiate a new putItem command, pass it the input item we just created, and log the response to the console. Let's run the test and see what we get. No errors, looking good so far. We'll know for sure when we fetch the data. Now for the final part of the test. I'll instantiate a new getItem command, passing in the key and table name. Once we get the response, I want to print a specific field, the color of the breed. I'll also add an assertion to check that the color matches what we expect. Alright, let's run this thing. And there we go. The test passed. We got the color we expected, and there's the whole item we retrieved. Alright, now we're about to make a big leap from NoSQL to SQL, so things are going to look a bit different. I'm going to show you how to run tests with PostgreSQL, and along the way, I'll also point out how you can do the same with MySQL. Make sure Docker Desktop's running in the background, then we'll hunt down the official database image on Google. Here's the command to spin up the container. We just need to add the port. Boom, the database is up and running. To confirm, we can run a quick query using the PSQL command. It's part of the PostgreSQL package, so if you don't have it yet, just Google download PostgreSQL and follow the install instructions. Looks good, the database is running. Now we can get started on the test script. For this, we're using the shell command client. Now, I know some of you might not love this approach. It's not the prettiest, but it's simple and it works. Trust me, I tried 5 different node clients for both PostgreSQL and MySQL, and they were all terrible, so this is the most reliable solution. But don't sweat it. What I'm about to show you works perfectly for test automation. The main goal here is to control test data, and with this approach we can do just that. Clear the data, create a table, insert some data, and fetch it. At the end of the day, we just need to verify that the data is correct. Whether it looks pretty or not doesn't matter. Testing is about finding and preventing bugs, not about writing the most elegant code. As long as it's simple and readable, you're golden. So first we'll import exec_sync from node child process, then we can run shell commands. I created a DB query function that executes those commands. Keep in mind, you'll need PostgreSQL installed to run the PSQL command. The script has a bit of double quote escaping. It took me a while to get it right, so make sure to copy it exactly if you want to use it. Alright, the function's ready. I'll add a comment here to show what it would look like if you were using MySQL instead. Now let's start by dropping the table to clear any leftover data from previous test runs. After that, we'll recreate the table and insert some values. It's just plain, simple SQL. Sometimes when you're dealing with complex JSON structures, you might find yourself wishing everything were as straightforward as SQL, or maybe that's just me being old school. Let's run this bad boy. Oops, looks like I made a typo. That parameter should be T, not R. Another hiccup. I know what's up here too. I originally made this test with a local database, not a Docker container. Let's tweak that line to point to the right database address. Okay, now the test runs, but we're getting an error. Table test DB does not exist. That's because we're trying to drop a table that hasn't been created yet. we need to wrap that drop table line in a try-catch block and just log the error to the console. Now we see the error, but the rest of the script's working. Run it again and poof, error's gone since there's actually a table to delete this time. Last bit of the script, reading those values we inserted. I'll fire off a query, print the response to the console, and throw in an assertion to make sure we're getting what we expect. And here are the results. You'll notice there's an extra new line character in the response. That's not something we added ourselves. I'm pointing this out because little things like that might need to be trimmed out of the response. Other than that, it works like a charm, super simple and effective. So, how do we integrate all these databases into Gitlab? It's actually pretty straightforward, and I'll walk you through it. Start by creating a new project in Gitlab. Once you've filled in the details, navigate to the pipeline editor. Let's tidy up the YML file a bit, and start with MongoDB. We'll set up the databases as services. Now, you could install the database through a script, but this is probably the most common way. The service definition includes the Docker image name and version. Remember, the service name also becomes the database address. So instead of writing localhost and port for your client, you'll use the service name and port. For illustration purposes, we'll also show the alias parameter. This lets you use Mongo localhost to access the database. I'm going to rename this job as Mongo Test Job, and later we'll add jobs for other databases too. First, we'll install the MongoDB node client, and then Mongosh. You only need Mongosh while testing the YML. Later you can skip installing it. This line tests if the database is running. We'll use the alias as the address with the default port. Let's run this bad boy. I'll fast forward so you don't have to wait. And there we go, job succeeded. Databases are up and running. Now, let's update our code to use the Mongo localhost address. While we're at it, we'll do the same for DynamoDB and PostgreSQL. Since this is just a demo, I'm keeping it simple. In a real-world scenario, you'd want to set up a variable that changes the address based on process.env.ci. That way, your address works both locally and in your CI pipeline. Now let's git add, commit and push. Heading back to the pipeline editor, we'll add steps to run the tests. npm CI will install Playwright from the package JSON, and then we'll install all the browsers needed for the tests. Finally, we'll run only the MongoDB test, not all of them. Let's fire this up again. Another success, the job ran successfully, and we can see the item we fetched from the database. Next up, we'll tackle Dynamo DB. We'll use Amazon's local database image as a service, with the alias Dynamo localhost as the service address. We'll comment out the Mongo DB service lines to avoid unnecessary delays in the pipeline. Additionally, we'll add a rule preventing the Mongo test job from running unnecessarily. First, we install the AWS CLI to set the region and access keys. If you were running Dynamo DB on AWS, you'd need real access key values. You can get them from the AWS console under Security Credentials. Let's commit this script and see if Dynamo DB is working. Looks like the database is running, even though it's empty. Back to the pipeline editor to finish the script. npm CI to install everything for CI, followed by browser installation, and then we'll run only the Dynamo DB test file. There it is. The test passed, but we've got some errors. These happen because the database starts fresh each time, so when we try to delete a table that doesn't exist, it throws an error. You can either ignore the error or adjust the try-catch block to log a brief message stating that the table was not found. Now onto the SQL databases. We'll remove any unneeded services and use the official PostgreSQL Docker image. The service name is Postgres, which is also the address. We'll need some environment variables, Postgres user and a host authentication method. I'll set it to trust because I don't want to deal with passwords here. If you need password authentication, set the Postgres password variable, but don't hard-code passwords in the YML. You can define password variables as masked in the project settings. We'll install the PostgreSQL command line client, PSQL, to make sure the database is working. Finally, we'll run a PSQL command to check the database's address. Looks like I forgot to add the database name variable. Let's fix that and commit the code. Everything seems to be working. Let's add the commands to run the test. npm ci, install the browsers and run the test. The test passed with errors again, but we got what we needed. The assertion passed and we can see the fetched data. The error comes from the test table not existing. You can handle that with a try-catch block and suppress the error message. Now let's integrate MySQL. I'll comment out PostgreSQL and switch to the latest MySQL image. The service address is MySQL. We need a couple of environment variables, the database name and the root password. I'll add the password here for simplicity, but normally you'd use masked variables in CI/CD settings. I'm adding a rule so the previous job doesn't run, giving Gitlab a break. We'll install the MySQL CLI to verify the database, and then run a MySQL command with the password, user, host, and any query you need. Remember, the host is the same as the Docker image name. We've got an error. Let's rename the job. Maybe we hit a reserved word or a job limit. I see now. It was just a simple indentation issue. These kinds of errors are fairly typical in CI/CD pipelines. Looks like the database is running fine. I didn't make a MySQL test since the SQL tests are basically the same for PostgreSQL and MySQL, so that wraps up our tutorial. I've shown you how to integrate Mongo DB, Dynamo DB, PostgreSQL and MySQL into a Playwright test environment, and run them in a Gitlab pipeline. If you found this video helpful, share it with your colleagues. If you have any questions, drop them in the comments. Thanks for watching.